In this video, we will be learning some important terminology related to periodic functions. So we're going to start off with looking at what a periodic function is. And it is a function that has a pattern of y values that repeat at regular intervals. So it's pretty much like you have a segment of your graph that is just copy-pasted over and over again. So if we zoom in here to these three examples, you can say this portion here is cut and paste over and over and over again in both directions. In the next one, you have this little hill that is copy paste. In the next one, you have this squiggle that would be going on in both directions. Whereas the next ones, they are not periodic because although the shape is somewhat similar, the y values aren't identical. You have this little triangular hill, but it gets larger and larger, so the y values increase as you go through. Same with the little jumps on the next one, and the stairs, they're all at different y values. Now that we know what a periodic function is, when a function is periodic, there are a few properties associated with it. First of all, the length of one complete pattern is called the period. So if you look at this function to the right, let's see why it is periodic. This function starts at this point, goes horizontal, comes up, comes down, and then it looks like it gets back to the start, but it doesn't because the pattern isn't repeating just yet. It goes horizontal, this time it comes down, up, and back to the start. Here is one segment. That's going to be copy paste because now if you look to the right of that, you'll see the same shape repeating. So what is the length? Well, it started at 0 and it ended at 8. So the period of this periodic function is 8. Next, we have the central axis or the midline. It is a horizontal line that is halfway between the maximum and minimum. So before we look at that, I'm going to identify my maximum. My maximum is 5, and my minimum, this is as low as my function gets, is 1. Now I can see the halfway mark between 1 and 5 should be right here at 3. If my numbers weren't the nicest, the middle is just the average of your max and mins. So we're just taking max plus min and dividing by 2. That is how we find the average of two numbers. So in this case, my midline or my central axis, I'm just going to short form it to mid, is y equals 3. I could have also shown it by doing max plus min, 5 plus 1, divided by 2. Now I'm writing y equals 3 because it is a line and I need an equation for this line, and it is y equals whatever that midline value is. Next we have the amplitude, and the amplitude is the distance from that midline we just found up to the maximum or down to the minimum. So if you look at the sketch, this here would be my amplitude, max to midline, or this distance here. It should be the exact same. And if I'm counting boxes, that's 2 boxes and 2 boxes there. So my amplitude is 2. Now again, if my numbers weren't that nice, I can subtract my max and my min. So if I were to do 5 minus 1, that would give me the total distance from max to min, and then I can cut that in half for the amplitude. So I could have done 5 minus 1, which is 4, divided by 2, which is 2. And of course, we also have our typical domain and range associated with this. My domain, I am assuming this is going on forever in both directions, even though there weren't arrows connected here. Because we are hitting the edge of the grid, it is implied that this pattern continues in both directions. So my domain is negative infinity to infinity, or if you're using the other notation, you could also write x is an element of all real numbers. For my range, because we have a minimum and a maximum, that really nicely covers our range. The lowest value we have is 1, the highest is 5. We include both of those values because there are points at those values. In the other notation, y is an element of all real numbers such that y is greater than or equal to 1, but less than or equal to 5. All right, let's take a look at a few more examples and identify these key properties. So first, is this first function periodic? Yes, it is. You have this zigzag that repeats over and over again. The second one is not, because the y values are changing as those zigzag patterns increase. And this last one is, it looks like I have this little curve wave repeating over and over again. Okay, for the two that are periodic, we're going to state the period, the range, the equation of the central axis, and the amplitude. All right, the period. Since I've already highlighted the length of the cycle, I just have to count. This period is going from -1 to 2, so that's 3 units. Now, I started my period like this, but I could have started it anywhere to count one length, one cycle. My maximum is 3, and my minimum is -1. Although I wasn't asked for this, it will help me with my range, my midline, and my amplitude. So for my range, we're from -1 to 3. For my midline, I mean, I can look at the visual. Maximum is 3, minimum is -1. The halfway mark looks like it's at 1. So I would write y equals 1. If I were to find it using my average, I could do max plus min, so 3 plus -1 divided by 2. For my amplitude, once I've drawn in my midline, I am just counting those two boxes, so it's 2. The visual is very helpful, and I just have to read my graph for it. Otherwise, I could have subtracted my max and my min to find the difference between them, and then cut that in half for my amplitude. All right, the next one. If you'd like to pause the video here and give it a try on your own before you come back to check, go ahead. Now, my period. My function started at 0 and ended at 6 for the cycle, so the period is 6. The maximum is 5. The minimum is -4. My midline. Now here it might be harder to estimate because the midline will be at a decimal, but you can still count your boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Half of that would be 4.5, so we're going 4.5 away from the max or the min. So I have a feeling it's going to be at around 0.5, but if we're not sure, let's average our numbers to find the middle. 5 plus -4 is 1, and when we cut that in half, there's the 0.5 that I was predicting. For the amplitude, now I can just count my boxes here. It looks like it's 4.5, but if I wasn't too confident in my counting because the midline was a decimal, I can do 5 subtract -4 to get 9, which is the total distance from max to min, and then cut that in half for the 4.5. All right, let's go to the next one. Given the following function, answer the questions below. Is this function periodic? Yes, it is, because we have this pattern right here repeating over and over again. Yes, because there is a pattern of y values repeating. And I'm just going to put the shape like this. That's what's repeating over and over again. And I'm putting that shape because that's how I drew it for my period. I mean, I could say that this is the shape that's repeating over and over again. It doesn't matter where you officially start your period. Okay, so the period is, based on what I drew, the period is 4 units. The maximum is 4. The minimum is -2. I'm going to do my central axis first. I can see it. 3 above, 3 below, there we go. It's y equals 1. You could, of course, also do 4 plus negative 2 divided by 2, so add the numbers, divide by 2. And now I can see my amplitude is this distance here. That's just 3 boxes. My domain, this is continuing forever, so negative infinity to infinity. And my range is from the minimum of negative 2 to the maximum of 4. Now we're going to bring back some function notation related to this periodic function. As a reminder, if the number provided is inside the bracket, that represents x. If it's the number after the equal sign, it would represent y. So here, the 2 that we're given is x. So when x is equal to 2, what is y? Well, here's x equals 2. This is the coordinate. So that's equal to negative 2. F at 5, well, 5 is here. Here's the point on the function. That's equal to 1. Now, f at x equals negative 2. Now we're being given the y value. So I go to negative 2 on my y-axis, and if I look across, there's actually quite a few values. We have 2, we have 6, we have 10. So I'm going to list the ones that are given to me, but it does continue forever. It looks like if I just keep adding 4 or subtracting 4, I will get all of the options. So there are more. And if I really wanted to be fancy, I could write this as an expression. So I can write this as take 2 and add 4 n times, where n is an integer, so a positive or a negative whole number. So this here would be an equation that technically would represent every single answer for f at x equals negative 2. But I would be fine just showing me the answers that you see on the graph, with the dot 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 to show that it does continue. All right, for the next one, I'm just gonna change that to 1. All right, f at x equals 1. So here's 1 on the y-axis, and we're looking for the x value. So there's 1, 3, 5, 7, 9 that we see. Dot 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 to show that it goes on forever. If I did want to write a general equation here, I could write x equals, I'm starting with the first number I saw, which was 1, and what am I doing from number to number? I'm adding 2 however many times I want. So that's what n would represent, the number of times I want to add or technically subtract the 2. The reason this would represent subtraction as well is because if I made n a negative number, then that would take us in the backwards direction. All right, determine the values of f at 0, f at 4, and f at 8. Okay, I'm just going to clean up this graph a little bit because there's a lot going on here. Okay, f at 0. F at 0 is equal to 4. Here's 4. F at 4 is also equal to 4. And f at 8 is also equal to 4. So they're all the same answer. And why is that? Because the points that we just found are the same point on the cycle. It's just a period later. So the period we know is 4 units. So if I add 4 to go from 0 to 4, I'm at the same point. I add 4 to the x value, and again, I'm at the same point. So this is the same point on a different cycle. Okay, so if I want f at 26, well, that's not on my grid. But what I can do is try to find an identical point on an earlier cycle. Now I know that the period is 4, so I'm going to take this 26 and subtract 4 until I hit a point on the function. So if I subtract 4 once, that takes me to 22. Again, 18. Again, 14. Again, 10. Okay, that's on my grid. So f at 26 should be the exact same thing, just 4 cycles earlier, as f at 10. And if I look at f at 10, that is equal to negative 2. Now, instead of subtracting 4 multiple times, I can just think of, okay, how many cycles fit in 26, and subtract 4 times that number of cycle. So for example, with f at 73, okay, how many times can I subtract 4 to the point that I get an x value that's on this grid? Well, I can try. 4 times 10 is 40. That's still too far. Maybe I try 4 times 15 is 60. 73 minus 60 is 13. I'm getting closer. Maybe I try 4 times 16. 4 times 16 is 64, and 73 minus 64 is 9. So f at 73 is going to be the exact same thing as f at 9. And now f at 9 is equal to 1. So again, I'm just putting the period here, and I'm picking a certain number of cycles so that when I subtract that number, I end up with an x value that I can see on my grid. Because this is much better than me extending this pattern until I hit an x value of 73. Okay, let's do some backwards questions here. Sketch 3 complete cycles of a periodic function with an amplitude of 3 and a period of 5. Okay, so we don't have too many restrictions here, but I need my amplitude to be 3, which means the distance from the midline to the max has to be 3, and from the midline to the minimum has to be 3. So I'm going to say, you know what, I want my midline to be at 0 to make my life easier, which means my maximum should be at 3, and my minimum should be at -3. And now if I want my period to be 5, I just need to make a shape in here that takes 5 units before it copy pastes. So I'm going to start here, and I want to end 5 units later in the exact same place. And then I'm just going to say, do a little mountain like this. And then I'll do another one, getting the same shape here. And then I'll do another one backwards. And it could have been any shape, as long as that amplitude is 3. So here's 1, 2, 3 for my amplitude. So I've checked that criteria off, and my period is 5. So I've checked that criteria off. All right, next one. Sketch 3 complete cycles of a periodic function with a central axis at y equals -2, so now they're giving us the midline, and a period of 4. So I am going to start off by drawing in that central axis. So here's my midline at -2. Now they didn't give me an amplitude, a max, or a min, so I have some freedom here. I'm just going to make my maximum 3 above and my minimum 3 below. There we go. So my max is going to be 1. My min is going to be -5. I could have done anything as long as I was balancing above and below that midline. And then the period has to be 4. So this time I'm going to start my cycle up here, and I have to end 4 later. I'm going to try to draw it more like little parabolas that are hopping. There we go. And then one backwards. And there we are. There's my periodic function. My central axis is at -2. My period is 4. The criteria is satisfied. All right, last question. An ocean tide is an example of a natural sinusoidal event. Now, we'll learn this another day, but sinusoidal is a type of periodic function, and it focuses on a sine function or a cos function. But for now, it's just that it's sinusoidal, it's periodic, kind of looks like a wave. At high tide, the height of the water is 12 meters. At low tide, the height of the water is 3 meters. That already, seeing high and low, reminds me of max and min. So the max is going to be 12, the min is going to be 3. I'm not even done reading yet, but I already have an idea of how to get my amplitude and my midline. So I'm actually going to do that. For my midline, I know what the midline is in the middle of the max and min, so I'm just going to take 12 and 3, add them, and divide by 2. That's 15 over 2, which is 7.5. And then my amplitude is going to be the distance from that midline up to my max, or to my min. So I'm going to subtract 12 minus 3. 12 minus 3 is 9, and 9 divided by 2 is 4.5. That might just help me sketch it later on. The ocean tide reaches its maximum every 12 hours. Sketch a graph of this phenomenon for 2 complete cycles starting at high tide. Okay, so I'm going to start off by putting time and height. That's already labeled, so I'm just going to label my scale here. Let's say 2, 4, 6, 8, 10, and 12. My maximum is supposed to be the 12, so I'm just going to highlight that. My minimum is 3. We've already calculated the midline to be 7.5. And once I draw that line in, I'm just going to double check that it is logical. So 1, 2, 3, 4.5. 1, 2, 3, 4.5. Okay, that's balanced nicely. And we're told that we're starting at high tide at time 0. And I do have to include 2 complete cycles. And we're told that every max height occurs 24 hours apart. So if I have a maximum at 0, I'm going to have another one 24 hours later, which kind of reminds me of a period here. So for my sketch, I'm going to say every 2 boxes is 2. So 2, and then that's 4. I'm just going to label every 4. Okay, so 24 hours later, we're back at a maximum, and if I add another 24, I'll have another maximum in there. Now, I need to draw a wave to represent this. We're going to have this gradual movement from the high tide to the low tide. And assuming things are going to be quite nice and symmetrical, if my maximums are 24 hours apart, I'm expecting the minimum to be right in the middle at the 12-hour mark. And then right in the middle between 24 and 48, right here at 36. Okay, and now I can draw a wave kind of going down. We will get more accurate once we learn what sine looks like and see more word problems, but for now, this is good enough. Okay, here we are. We have this curve, it's periodic, the max is 12, the min is 3. Every 24 hours, this maximum is occurring. So now, let's fill in some properties. The period, 24. The maximum, 12. The minimum, 3. The amplitude we already found was 4.5. The central axis was at 7.5. Now, in terms of the domain and my range, I'm going to do it for this specific scenario because we drew 2 cycles and that's all we were asked for. So my domain is from 0 hours to 48 hours, and my range is from that minimum of 3 to that maximum of 12. What is the approximate height of the water after 4 hours and 12 hours? Okay, so I'm just using my sketch here. So after 4 hours, it looks like approximately 10, and after 12 hours, it's at that minimum of 3. So 10 meters and 3 meters. And finally, at what other times will the height of the water be the same as it is at 6 hours? So let's first see what the height is at 6 hours. So 6 is here, so looks like maybe around the 8 mark. Here it is again, here it is again, here it is again. So it looks like at 18 hours, at maybe 31 hours, maybe 43 hours. Now again, this is not the most accurate because we did estimate this curve. So I'm just gonna write at 18, 31, and 43 hours. And it is an approximation because I'm just reading my sketch, which isn't the most accurate because we don't have that sinusoidal knowledge just yet, but at least we're getting a sneak peek for the sinusoidal function word problems. And that's it for your intro to periodic functions.